this video, we're going to talk about solving quadratic equations by completing the square. Before we just jump into completing the square, though, I want to understand the square root property. So the square root property is if you have a value being squared, so like a squared equal to b, then to solve for a, you want to get rid of the squared. So how do we get rid of squared? We take the square root of both sides. So it'd be like taking the square root of a squared and the square root of b. So a would equal the positive and negative square root of b. And it has to be positive and negative because of the fact that if you have like negative 2 squared, that's positive 4, and positive 2 squared is also positive 4. So you want to account for both the positive and negative. So that's why when you have a squared, you set it equal to a equals plus and minus the square root of b. So example 1, x squared equals 75. To solve for x, the x squared is already by itself on one side of the equal sign there. So we take the square root of both sides. So we get x is equal to plus and minus the square root of 75. And then we're not done just at that step, because now we have to solve or simplify the radical. So 75 is 25 times 3, where the square root of 25 is 5. So we'd have plus and minus 5 square root of 3. So our answers would be positive 5 root 3 and negative 5 root 3. And writing it just like this is fine too, but just understanding that I have a positive 5 root 3 and a negative 5 root 3. So number 2, 3x squared minus 21 equal to 0. I'm going to add 21 to both sides. Get 3x squared equals 0 plus 21 is 21. Our whole goal right now is to get the x squared by itself. So now I'm going to divide by 3. Get x squared equals 21 divided by 3 is 7. Now I'm able to just take the square root because I have the x squared by itself. So take the square root. X equals the positive and the negative square root of 7. So our answers, positive root 7 and negative root 7. And again, this answer is completely fine. You don't have to separate into the two. But in a minute, when we get to completing the square, you're going to want to understand that a little bit better, how it just breaks up into two. Number 3, x plus 1 squared equal to 18. So a little bit different, where on like number 2 and the previous one, number 1, I just had like an x squared. Just the x was being squared. So here I have x plus 1 being squared. But in its current status, the x squared is by itself. Like the whole term being squared is by itself on one side of the equal sign. So since that's already by itself, we can move forward with just taking the square root of both sides. So I'm going to be left with x plus 1 rather than just x, because the x plus 1 is being squared. So now I'm left with x plus 1 equals the positive and negative square root of 18. Well, before we move forward, square root of 18 can be simplified because 18 is 9 times 2. Square root of 9 is 3. So we get 3 root 2. So let's rewrite this. So that means I have x plus 1 equals the positive and negative 3 square root of 2, because 18 was 9 times 2. Square root of 9 was 3. So I get 3 root 2. Now I'm not done though, because I don't have x by itself. I want to get x by itself. I'm going to subtract 1 from both sides. So I get x equals negative 1 plus and minus 3 root 2. And the reason I'm writing it like that rather than positive negative 3 root 2 minus 1, you could write it like that also. Like you could write this as x equals positive and negative 3 root 2 minus 1 like that. That's fine, actually. But I just wrote it like negative 1. All right, let's look at number 4. So for 3x minus 5 squared, you'd want to take the square root because the term being squared is already by itself. So I'm going to take the square root. I get 3x minus 5 equals the square root of negative 49. Well, there's a lot going on here. Sorry, plus and minus. First of all, Square root of 49 is 7, but I have a negative, so we have to pull out I. So this is going to be 3x minus 5 equals positive negative 7i. Because the square root of 49 was 7, and then that negative inside a radical, you have to pull out I. So the square root of negative 1 is I. So I have positive negative I, 7i. Now we're basically just solving an equation. That's all we want to think about here. So I'm going to add 5 over. 3x equals positive 5 plus and minus 7i. And we talked about this form in one of the previous sections about how we write it as like a plus bi, something like that. So that's why I'm writing it like that. And then we want to divide by 3. So I would get x equals 5 plus and minus 7i all over 3. So the technicality here, like what would this solution actually look like? I'm going to go this way because I know I'm getting close to my camera here. So the technicality here would be this is 5 plus 7i all over 3 and 5 minus 7i all over 3. So just that plus minus just indicates that we have a 5 plus, and then that minus 5 minus 7i. So those would be our two potential solutions on this one. But writing it like this is perfectly fine. But you do want to understand how to break these up into two. So completing the square, this leads us into completing the square. Completing the square is when we have a trinomial. It's another form of kind of like factoring, but not exactly factoring. So solving by completing the square is just another method. We want to focus on perfect square trinomials is what we're looking at for completing the square. So perfect square trinomials. And what I mean by that is if we have the perfect square trinomial of like x squared plus 8x plus 16. This is a perfect square trinomial because when I factor this would be x plus 4 times x plus 4. Two numbers that multiply to 16 and add up to 8. 4 times 4 is 16. 4 plus 4 is 8. So what we'd really write this as is x plus 4 squared. It's a perfect square trinomial. The relationship you want to see here is the relationship between this middle term and this. If I take this middle term, so if I take 8 and I cut it in half and I square it, what do I get? 8 divided by 2 is 4. 4 squared, 16. That's the relationship that we want to be aware of right now. So if I have the trinomial of ax squared plus bx plus c, I'm going to take this b term and I'm going to divide it by 2 and I'm going to square it. So I'm going to put a little, let's keep this in mind. So let's take a look at this problem. Because we're going to need to know that in order to complete the square. Because we want to create a perfect square trinomial. So on this number 5, solve each problem by completing the square. X squared plus 12x equals negative 20. So when we're completing the square, we want these terms on the one side of the equal sign by itself. And then we want that constant on the other. So this is fine. So like technically like right here, if I go back to this, I would want this as ax squared plus bx equal to the c term. So like I'd want that c on the other side because I'm going to try to create a perfect square trinomial. And that c term does not allow me to. So I have to move that over. So I have this x squared plus 12x. To complete the square, I'm going to take this b term, 12, divide it by 2, and square it. So I'm taking this b term, so b over 2. So we're taking the b term, cutting it in half, and then squaring it. So this, in this case, it's going to be 12 over 2, which is 6. 6 squared is 36. 6 times 6. I get 36. That means I want to add on 36 to both sides. So I'm going to have x squared plus 12x plus 36 equals negative 20 plus 36. So I'm adding on 36 to everything. Both sides of the equation needs that plus 36. I can't just put 36 on the left side just to make it a perfect square trinomial without offsetting that change on the right side. So I have to put that plus 36 on both sides. So this is plus 36 that I'm adding on from the b over 2 squared. Now, look what happens. This is a perfect square trinomial. X squared plus 12x plus 36 factors to x plus 6 squared. 6 times 6 is 36. 6 plus 6 is 12. So that factored to a x plus 6 squared, or x plus 6 times x plus 6. But we want to write it in this perfect square trinomial form where it's x plus 6 squared. And you'll see why in a second. Equals negative 20 plus 36. 36 minus 20 is 16. Now we use the square root property to solve. I have a term being squared by itself. So now we take the square root of both sides. So we get x plus 6 equals plus and minus the square root of 16 is 4. Solve for x. Subtract 6. So we get x equals negative 6 plus and minus 4. In this case, you want to go forward and separate into the two, because I could actually do negative 6 plus 4. I could do negative 6 minus 4, where before, let me go back a second, like on like this one, negative 1 plus 3 root 2, negative 1 minus 3 root 2. Can't really, those are not like terms or anything like that. I can't do negative 1 plus 3 root 2, so I would just leave it as that. But in this case, I could actually do negative 6 plus 4, negative 6 minus 4. So x is going to equal, x is going to equal negative 6 plus 4, which is negative 2. And x equals negative 6 minus 4, which is, getting close to my camera here, negative 10. So our solutions are negative 2 and negative 10. So right here, negative 2, negative 10. There we go. So on number 6, x squared plus x minus 1. And what you might notice, like these trinomials here, these are not factorable in current form. They're not factorable. I cannot find two numbers that multiply to negative 1 and add up to a positive 1. So I can't factor that using just standard methods. So I want to add 1 over to both sides. I want to get it into the completing the square form. So I want to add a 1. I want to get that over. So I'm going to have x squared plus x equals 1. 0 plus 1 is 1. Now let's complete the square. So I'm going to do the b term, which is just 1. This is a 1x, so it's 1 over 2. The formula here is b over 2 squared. b over 2 squared, this right here. b over 2 squared. So the b term is 1 over 2 being squared. 1 over 2 squared is 1/4. 1 times 1 is 1. 2 times 2 is 4. So I have to add on a 4th to both sides. This creates a perfect square trinomial. And in these fraction forms, like this is kind of a hard, like you might not think like, well, what is the perfect square trinomial, or like x plus what squared? Just think of it this way. Before you made that squared, you got that 1/4. This is what it's going to be, this 1/2. So it's going to be x plus 1/2 squared. Let me rewrite that. X plus 1/2 squared. And if you go back to the last one, we got 6 for the b over 2. So look at our perfect square chart, our factored form, x plus 6. So here it's 1/2 then squared, so it's going to be x plus 1/2. But you got to make sure you add on that 1/4 to both sides, equals 1 plus a 4th. Go through that kind of quick, 5 over 4. 1 plus a 4th is 5 over 4. Now we have to use that square root property because we got the x term that's being squared by itself. So let's square root both sides. Oops. X plus a 1/2 equals this plus and minus square root of 5 over 4. So this is kind of tricky here because I can simplify this radical of square root of 5 over square root of 4. So let's do that. So x plus a half equals plus and minus square root of 5 over the square root of 4, which is 2. So let me go up here. X plus a half equals plus and minus square root of 5 over 2. Because square root of 4 is 2. Get x by itself. So I'm going to subtract a half from both sides. So minus a half. So x equals negative 1/2 plus and minus square root of 5 over 2. And luckily, in this very rare scenario, those denominators are the same. So I could actually just write this as x equals negative 1 plus and minus the square root of 5 all over 2 like that. Or you could separate it into 2, negative 1 plus square root of 5 all over 2, negative 1 minus square root of 5 all over 2. I'm kind of running out of room on this problem here. So I'm going to just leave it like that. But you could separate it into the 2 if you would like. Maybe I'll just write it over here. I'll write it over here. So I'm going to do negative 1 plus square root of 5 all over 2. And negative 1 minus square root of 5 all over 2. So those would be my two solutions there. Now, in number 7, there's a little bit of an issue. 4p squared plus 12p plus 3. The issue is this a term. This is a 4. We want the coefficient to be a 1. So we want that to be a 1. That means that we want to divide everything by the 4. And on those last couple problems that we did, that wasn't really the case. Like 1x squared, 1x squared. So we didn't have to worry about that too much. But we do want to divide everything by 4. So that's going to be p squared plus 12p divided by 4 is 3p plus 3/4 equals 0 divided by 4 is 0. So that's nice. Okay. Now, we want to get it into the structure of completing the square. So I want to get rid of the c term. So I'm going to subtract 3/4 from both sides. So I get p squared plus 3p equals 0 minus 3/4 is negative 3/4. All right, now we are ready to complete the square. So let's take the 3 divided by 2, because we're taking this b term, divided by 2 and squaring that. So that's going to be 9 over 4. So we are adding on 9/4 to both sides. Factor, it's a perfect square trinomial. So this is going to factor to p plus, and then I just use this term right here, 3 over 2, to factor. So 3 over 2, and then all being squared, equals negative 3 over 4 plus 9 over 4. 9 minus 3 is 6, 6 over 4. That actually simplifies. 2 goes into 6 3 times, 2 goes into 6 twice. So I'm going to simplify that down if that's okay. That's just, so again, this is just going to be 6 over 4. And that's going to simplify down to 2 goes into 6 3 times, 2 goes into 4 2 times. So 3 over 2. Square root property. Take the square root of both sides. So I'm going to go over here. Getting close to my camera. So p plus 3/2 equals positive and negative square root of 3 over 2. And that doesn't simplify at all. Like the square root of 3 over the square root of 2 wouldn't do anything for us. So we could just probably actually want to... Do we want to rationalize that? Let me think about this for a second. Yeah, I think we should probably rationalize this. So let's write this as p plus 3 over 2 plus and minus the square root of 3 over the square root of 2. And the reason I'm going to rationalize it, because if I'm going to subtract 3/2, like I'm going to have this denominator, so I want to probably simplify that a little bit. So I'm going to rationalize this by multiplying by 2, and I know I'm like right up against my camera, so I got to move this. Multiply this by 2. I'm going to erase this stuff here. All right, so I'm going to go over here. So p plus 3 over 2 equals positive and negative square root of 6 all over 2. Because square root of 3 times square root of 2 is square root of 6. Square root of 2 times square root of 2 is just 2. And then now I can subtract the 3/2, and we'll be in pretty good shape from here. So p equals negative 3 over 2 plus and minus square root of 6 all over 2. Then now, since I did that, now I could see that, well, I'd have negative 3 plus square root of 6 all over 2, and then negative 3 minus square root of 6 all over 2. Or if I didn't rationalize, it'd be a really messy looking fraction. But rationalizing it makes it a much cleaner answer, much more reasonable. There we go. All right, let's do one more, then we'll look at a application. So number 8, 3x squared plus 11x equal to 42. So again, this is not 1. So we want to make it 1 by dividing by 3. So I get x squared plus 11x over 3 equals 14. 42 divided by 3 is 14. Let's complete the square. So I want to take the b term of 11 over 3 and divide that by 2 and square it. Fractions you got to be careful with. So this is 11 over 3 over 2 over 1. So 11 over 3 times 1 over 2 technically. So that's 11 over 6 because if I'm doing 11 over 3 divided by 2, that's 11 over 3 divided by 2 over 1, which is multiplying by 1/2. So it's 11 over 6 squared, which is 121 over 36. Extremely messy fractions here. So I get 3x squared, let me be mindful of my space here. Not 3x squared. X squared plus 11x over 3 plus 121 over 36 equals 14 plus 121 over 36. And then we factor. So this is going to be x plus 11 over 6 squared. Let's say 11 over 6 before you square it. Equals so this is 36. This becomes 504 plus 121. So 625 over 36. This looks really scary, but something's going to happen here. Take the square root. And look what happens. So again, this looks really scary with these fractions, but look. This is 11 plus 11 over 6 equals plus minus square root of 625 is 25. The square root of 36 is 6. The radicals simplify. That's really, really awesome that happens. That is really nice. It's pretty exciting. So then now I just have a pretty manageable problem. So I'm going to subtract 11 over 6 from both sides. So I get x is equal to negative 11 over 6 plus and minus 25 over 6. And then we could really expand on this more. So let's go up here. So I'm going to set this up as x equals negative 11 over 6 plus 25 over 6. And then I'm going to also do negative 11 over 6 minus 25 over 6. And we should be able to clean this up pretty nicely. So let's see, 25 minus 11 is 14. So we get 14 over 6. Which simplifies down to 7 over 3, right? 2 goes into 14 7 times, 2 goes into 6 3 times. So 7 over 3. Then this is going to be 11 plus 25, because they're both negative, so negative 36 over 6, which is negative 6. So there's our two answers, 7 over 3 and negative 6. It was probably one of our cleanest answers that looked like one of the messiest problems with these crazy fractions and everything. But this radical cleaning up nicely really helped us out. So that's pretty cool. Then finally, an interest problem, just using the square root property. So we have the formula A equals P times 1 plus R raised to the T, where R is the rate, and then T is the time, P is the principal, and then A is going to be that value that we get. So we want to find the rate at which R at which $5,000 compounded annually grows to $84.50 in 2 years. So our P value is 5,000, and our A is $84.50, and our time is 2 years. Rate is the unknown. That's what we're trying to figure out. We want to know what is rate in this problem. So let's plug in the information. So the future value here is $84.50 equals the principal, 5,000, times 1 plus the rate, which we don't know, so that's 1 plus R, raised to the time of 2. Now we're just solving a problem, solving for R. So we're using the square root property. I got to get that by itself, so I'm going to divide by 5,000. So we have 84.50 over 5,000 equals 1 plus R squared. Let's simplify 84.50 and 5,000. Let's divide those by 5. Let's try. I'm sure we can go bigger, but let's try 50 actually. Yeah, 250. So I'm gonna divide both of these by 50. So 84.50 divided by 50 is 169. And then 5,000 divided by 50 is 100. So then we get 1 plus R squared. I was going to do 5 and then 10, but 50 works too. Let's take the square root now. So we get 1 plus R equals plus minus, look what happens, square root of 169, 13, square root of 100, 10, so 13 over 10. Subtract 1 from both sides, R equals negative 1 plus 13 over 10, and R equals negative 1 minus 13 over 10. Look at our potential answers, though, and justify which one would make sense. So we have R is equal to negative 1 plus 13 over 10, which would be, this would be 10, so this is negative 10. So this comes out to be negative 10 plus 13 is 3 over 10. And then the next one, this would be over 10 over 10. Negative 10 minus 13 is negative 23 over 10. That's a negative rate. We can't have a negative rate. So that answers out, so it's going to be 3 over 10, which would translate to 30%, or 0.3. So 30% each year. All right, and there we go.